What's going on? Welcome back. In today's video, we're going to talk about Network Services Part 2 from TryHackMe. And if you remember in the, not the last video, the video before the last video, we have completed the Network Services Room 1. And now we are on to Network Services 2 Room, which is also part of CompTIA Pentest Plus. Once we finish this room, we're going to move on to Active Directory, and we are done with CompTIA Pentest Plus pathway. So in this video, we're going to break down these tasks into 3 compatible videos. Or not compatible, why did I say compatible? Into 3 equal videos. So task 1, task 2, 3, 4 for NFS, video 1, which is the one we are currently doing, 5, 6, 7, next video, 8, 9, 10, and the last video. All right, so NFS, of course, it is for network file sharing. NFS is much like SMP. If you remember, if we get back to the rooms here, breakdown, and we look for the network services 1, network services 1, yes. So we have talked about SMP, right? Which is much like NFS. So NFS and SMP are the same for sharing files between a client and a server. So the client can access the files on the remote server as if they are accessing the files on their local machine or their local system. So that's the purpose of NFS. And NFS is much faster than SMP. Okay, now we're going to go over these. I'll just summarize what is this task. So I'm going to go over the answers, explain them. What does NFS stand for? Network File System. What process allows an NFS client to interact with a remote directory as though it was a physical device? So this is the object of the NFS. Through NFS, a client, right, can interact with a server or remote directory on the server with the mounting service. They can mount the directory. You have heard about the word mount. You mount a file on your system. That's NFS. So how do you do that? Mounting. What does NFS use to represent files and directories on the server? So when you have a directory on the server and you share this directory using NFS, every file inside this directory has a file handle through which the user can access it and list the permissions. What protocol does NFS use to communicate between the server and the client? So RPC is the protocol used, right, to communicate between a client and a server on the NFS. What 2 pieces of user data does the NFS server take as parameters for controlling user permissions? So basically, when a client accesses a directory or a shared directory mounted, right, with a server, so basically the server checks if the client or if this user or if this person, user's ID and group ID, determine the access level, read, write, modify, whatsoever. Can a Windows NFS server share files with a Linux client? Absolutely, you can do that. So if you have a Linux client sitting on a network and a Windows server, basically you can let the Windows server share a directory with a client Linux, and you can use the mount command of Linux to mount that directory. Of course, you're going to configure the permissions to make sure everything stays secure. Can the Linux NFS server share files with a Mac OS? Absolutely the same process. Actually, why we can do that between different systems? Because this is protocol reliant. It relies on the fact that you are using NFS and RPC. What is the latest version? This is 4.2. And done. Now we're gonna on to enumerating NFS and exploiting NFS. So for that reason, we're gonna minimize this. So the first thing for the enumeration, we scan the machine. So we have -3 enumerating the services and the version, -A for the aggressive scan, and we can see we have three open ports: 22, 111, 2049. 22 for SSH, 111 for RPC, of course. This is used for communicating between a client and a server when NFS is enabled. NFS is, as you can see, running on port 2049. Now, once we find that there is was specified that the remote target is running NFS, the next point is to figure out and find what are the shares, right, that the server is sharing with the clients. So we see NFS, right, much like when we have a client running SMB and we run enum for Linux and SMB client to connect to the shares and list the shares. The same with NFS, but instead of using enum for Linux or SMB client, we use Showmount. So Showmount, we can see the shares. So what do we do? Sudo Showmount. That's the command, -e, and we put the IP address of the target. Go. So we have this directory, which is shared. Now, we have seen the directories. The next step is we mount them, right? So we listed the shares. Now we want to mount them on our local system. So now we are the client. This is the server. We have figured a directory here, shared, ready for mounts. We're gonna mount it. So how do we mount it? Before we mount that, we're gonna create a directory on our local machine to host the mounted directory here, right? So sudo, and then make directory. We can mount it in, if you are doing that for experimentation, we can mount this into temp directory since this will be erased after the restart. Now, if you are just doing some client-server communication for work whatsoever, you can select the point that will host the directory and mount it. So you are not bound by the temp directory. You can choose whatever directory you want. So temp, and here we name the directory mount. This is on our local machine that will host the mounted directory, this one. Okay, so cd temp. We have the directory here. Now, what's the next step? The next step is to mount that directory. So we use the command sudo mount. We specify the NFS, right? Sometimes you use CIFS, and there is much difference between NFS and CIFS. We can talk about this later, but now we can use NFS. And then we type the IP address of the server. In our case, it is server and it is target, since we are doing pen testing here. And here, semicolon, and we name the directory that we want to mount, which is home. Okay. Now, where we will mount this directory, of course, on our local machine, to temp mount, and then we use no lock. Let's see. Okay, we are finished now. We are finished with that. The next step is to go to the directory on our local machine and explore what's in there for us. ls cd mount ls. So we have one directory. Okay, so we can see to that directory cappuccino. Okay. So what do we see here? We see the directories and files that are shared with us. Okay. Now any change we do here will replicate to the server. Okay. Since we have access permissions to the mounted share, right? Whatever change, whatever file we put here, okay, it will be replicated to the NFS share. Of course, why? Because we have permissions to do that. Now, the interesting directory is SSH. So cd.ssh. And we have the private key. So we can do the following: sudo copy idrsa to home. Right. Now we split that. You split home. So now we want to use that key to log in. But before that, we adjust the permissions. Sudo node 600. Now SSH-I IDRSA, and here we want to define, of course, the username, right? So how do you find the username? Actually, if you go up here, okay, you can see we can deduce from the name here that this might be the username. So we take it, okay, and now here what do? We paste that at, let's get the target IP. Let's try to log in now. Cappuccino password. No, we should not be doing that. Why? I need the password. Yes. Okay, now it worked. So right now we have logged in as Cappuccino. Now this is the typical way of exploiting network file share. If you have found out that it is running and there is a share running on the server, and you can mount it and access whatever you want. You just look through and find something you can use to have low privilege shell. So if you type ID here, the ID is Cappuccino. Now, since we have done the first step in the exploitation, of course, gaining limited access, the next step is doing privilege escalation. So, how do we escalate our privileges? We have two options. We either use that session, okay, and do regular, typical, ideal Linux privilege escalation by uploading whatever script you have, linpiece. You can transfer or you can convert this session into a meterpreter shell and run exploit suggester. You just do it regular Linux privilege escalation, but that's not the objective of this video. The objective is to use NFS, to rely purely on NFS to do all the exploitation. Now we have got limited shell, that's great, but we need to also escalate our privileges from the NFS access we have, which is up here, right? So one way to do that is to try, here we are on the share, right? And I have mentioned that if you upload any directory, any file, directory, whatever, to the share on your local file system, it will be replicated or copied, the change will be replicated to the server. So what if we upload an exploit to the NFS share and we run it from the server? If you run it from the server, we're gonna have what was it? Root access. So for that reason, the room here suggested that we use this exploit. Let's look at this exploit. So this is bash, as you can see, and what it is suggesting is to download this binary to our local machine, transfer it to the mount point we have on our local machine, giving it the SUID bit permission, and run it from the server. Let's see how do we do that. So let's take this first, and from the local machine, or from the Linux here, Kali, we download it. Okay. So you might be wondering, how can we prevent this attack, right? We're going to talk about this. All right, so now let's do split here one more time. cd bad, or cd home. So we have it here, okay? Now, simple copy sudo of cp bash to temp mount. No? What happened? Okay. So cd back, ls. I have bash here, right? Now what do we need to do? Let's copy bash, mv bash, cappuccino. Permission denied. Okay, fine. cd cappuccino. Right, so it is in here, in the directory. Now, this is my local machine, right, from the mount point. I'm gonna jump now to the server side and see if the binary here has been copied to the server side. Okay, so we can see it is here. Now, before running it, we have got to give it SUID bit permission, right? So before doing that, let's run sudo chmod plus s bash sudo, and then we give it execution permission bash. Check on that. So bash now has the SUID bit set, and as all of you know, when we have the SUID bit set, it means that the file can run as its owner. So let's check the permissions on the server side. Seems like we have got a hiccup here. Okay. So bash now, as you can see, has the SUID bit set. Yes. So if you run bash now from the server, it will run as root, right? So let's try that. ID. Oh, same. Nothing changed. All right. So bash -p. Okay, now it worked. So why it worked with p, right? P used as stands for persist, right? So when we type -p, it forces the binary to run as the owner permissions, which is owner permissions are root, right? That's what it does. Forces the binary to run as its owner. So right now we have got root access. So what's left is to get the flag, and that's not our big deal, but we're gonna look for the flag. cd root cat root. Okay, NFS got pwned. Cool. Let's see the flag. All right, now the flag is correct, and we have got this. Now, let's see why this all happened. How can we prevent this? The first thing, on the server side, this is the server, okay? Now, you have a shared directory, right, with NFS. You've got to choose who and what who can access what and what can be accessed, right? So right here, I was the anonymous user. I mounted the share without any problems. I was able to modify, read, write, whatever I want. The first problem is misconfiguration, security misconfiguration, or we call it permissions issue. That's basic. We can get around this. Now, what if someone has access to your NFS share with an authenticated user? Let's say that they have brute forced the user whose password is weak, and they have got access to your NFS share. Now, what if they can put something like that and give it SUID permissions and run it on your server? How can we prevent this? We can prevent this simply by enabling something called root squashing. Root squashing, let's see, if we enable that, we can prevent anyone from putting files on the NFS share and giving it SUID permissions. Root squash. NFS. You can research about it and read it. Root squash is a special mapping of the remote superuser identity when using identity authentication. Under root squash, a client's UID 0 is mapped to nobody. It's primarily a feature of NFS, but may be available in other systems as well. So in our case, this was disabled. Okay, you've got to make sure that it is enabled so it can prevent anyone from running as root on your NFS file share. We don't want that. Can you research more and read about this? Now, let's get back and answer the questions. So, enumeration. Conduct a thorough report scan of your choosing. How many ports are open? There were 3. Wrong? Let's check the ports. 1, 2, 3. What's wrong with that? Three ports. Well, I think there might be more than 3 ports, but I choose this scan that doesn't scan all ports. So what we would do here, we would rescan -p and see how many ports are actually opened. Can take time, but we're gonna skip to the next questions, and if this finishes, we're gonna see how many ports. If not, you can do it on your own, not big deal. Which port contains the service we're looking for? 2049. They mean the NFS. Now use user pin Showmount-I to list the NFS shares. What is the name of the visible share? It was home. Then use the mount command we broke down earlier to mount the NFS share to your local machine. Change directory to where you mounted the share. What is the name of the folder inside? Okay, it was cappuccino. Okay, interesting. Let's do a bit of research now. Have a look through the folders. Which of these folders would contain keys that would give us remote access to the mesh server? It was .sh. Which of these keys is most useful to us? Of course, you know the answer. ID, RSA. No, they need to look. You don't need to look. Can we log into the machine using SSH-I key file username IP? Yes, why not? Okay. Not finished. Okay, next. Exploitation. Completed. Now we're going to add the SUID bit permission to the bash executable we just copied to the share using sudo sysmod permission bash. What letter do we use? What letter do we use to set the SUID bit set? Using chmod, it was S. Let's do a sanity check. Let's check the permissions of the bash executable using ls-la. What does the permission set look like? Make sure that it ends with dash srs. Oh, okay. Let's see the permissions. Go down. Okay, let's take these permissions and answer with them. This is completed, and now this is done. Now let's see how many ports. Still scanning. Okay, I'm going to leave that to you. You're going to be able to find how many ports. It's not a big deal, you know. And that was about NFS. What's next? SMTP. Simple. This is for, and we have MySQL. Okay, this is for emailing, and this is for database. All right. Thanks for watching.